Hello friends, welcome to my YouTube channel Glowing Lessons. This is in continuation with my previous class 10 video on chapter 1. See my video on Euclid's division lemma. Please, before proceeding in this video, please see it first and then come back to this video. Now this video represents Fundamental Theorem of Arithmetic, which will be my second e-lesson of chapter 1. If you find this video helpful for your preparation, please hit the like button and subscribe my channel for more such videos. Now let's just get started. Fundamental Theorem of Arithmetic. Before proceeding to this Fundamental Theorem of Arithmetic, let's just talk something simple. Let's just first talk about something simple stuff. For example, in earlier classes we have seen that every natural number, or to be more precise, every composite number can be written as the product of its prime factors. For example, let's just take 6, 10, 15 or a bigger number like 253. 6 you can write it as 3 into 2. 10 you can write it as 5 into 2, product of their prime factors, 5 into 3, and 250, a bigger number like 253, can be written as 23 into 11. See, both are prime numbers, right? Now the question that will arise in our mind is, can we produce all composite numbers in the form of like this? Can we do that? What do you think? Is it so? Before answering your question, or before getting an answer to this question, let's just factorize some numbers. Don't watch this video idle. Take a pen and paper and do it with me. 126. Let's just factorize these numbers. What you'll get? 32, 16, 8, 4. Here you get 256 as 2 to the power 8, right? Am I right? Now let's factorize 126. 2, 63. 63 will not go by 2. Then we'll take 3 as prime factor. It will take 21, 3, 7. 126 can be written as 2 into 3 to the power 2 into 7, right? If you take any composite number and factorize it, you will find that it can be written as the product of its prime numbers, product of its prime factors. This is nothing but your Fundamental Theorem of Arithmetic. Now let's just see what does Fundamental Theorem of Arithmetic says. It says that every composite number, whether it is 6, whether it is 12, whether it is 1, 5, 6, 7, whether it is a number of 8 digits, it can be expressed or factorized as a product of the product of primes. Okay, and its factorization is unique. This will be unique for 6, this will be unique for 12, this will be unique for 1, 5, 6, 7. Any number which you will take, it will be unique for every number, apart from the order in which the prime factors occur. It doesn't matter whether write 3 into 2 or 2 into 3. The factorization, the product of primes does not depend on the order, because we know in earlier classes we have learned that the A into B is equals to B into A. This is the simple and basic rule for multiplication. Now let's just see one question on this. Find the HCF and LCM of 6 and 20. How can you write 6? You can write 6 as 2 into 3. How can you write 20? You can write 20 as 4 into 5. 4 is not a prime number. Then you can write 2 into 5, right? Now let's find HCF. How will you find HCF? Do you know the basic rule for finding HCF? It is the product of smallest power of each common factor. What are the common factors in this? You have only one common factor, 2. What is its smallest number? 1. So HCF for 6 and 20 comes out to be 1. Let's see what is the basic rule for finding LCM. It is the product of greatest power of each number that occurs in prime factorization. Okay. What are the numbers which are occurring in prime factorization? 2. It's 2, 3 and 5. What are the greatest power for them? 2. For 2 I have 2, 1 and 1 for them. I'll get 60 from here. Okay. Now the question arises, how I'll remember that what I have to find, the product of smallest power or greatest power. For that I have a small trick for you, which says, if you have to find HCF, full form of HCF is highest common factor, then just go with the opposite of HCF. It says the product of smallest power. This happens in the case of LCM too. Least common multiple, opposite of least, greatest, right? It will have the product of greatest power of each number that occurs in prime factorization. Okay, there's one more interesting fact which you'll get in this chapter, which says that for any two positive integers, remember this, two positive integers a and b, the product of their HCF and LCM is equal to the product of their numbers, right? Let's verify this with our previous example. See, HCF is 2, LCM is 60. Product, if I find out the product, it will get 120, right? And what were the numbers? 6 and 20. If I find out the product for these two, I'll get 120 here too. This verifies my this interesting fact. Okay, let's see one question based on this. Given that HCF is equals to HCF of 306 and 657 is 9, you have to find LCM. One basic method will be find the prime factors of this, find the prime factors of this, and then find out the LCM. But if this question comes for 1 mark, how will you encounter this? Is it worth to take that much time on this question? No, right? For that, we'll use this fact which we have just seen, HCF into LCM is equals to A into B. As it is talking about two numbers, HCF is 9 into LCM 306 into 657. Here I get 3s are 27, 36 comes out in 4. I'll get it as 22338. Okay, I hope this is clear to all. Let's move to next question. Find the HCF and LCM of 6, 72 and 120 using prime factorization method. For 6, if you do the prime factorization for this, it is very simple. You'll get this. Write down the prime factors here, 3 into 2. Okay. Now do the prime factorization of 72. And for 120 as well. it will give me this. Okay, now just write them here. 72 is equals to 2 to the power 3 into 3 to the power 2, and 120 as 2 to the power 3 into 3 into 5. Let's find out the HCF. HCF, highest common factor. That means I have to find out the product of common factors with smallest power. 2 into 3 are the two common factors. 1 is the smallest power for both of them. Then my HCF comes out to be 6. If I talk about LCM, LCM least common multiple, with it means I have to take all the factors which are occurring in the prime factorization with their highest power. For 2 I have 3, for 3 I have 2, for 5 it's 1. It comes out to be 360. Okay, here that rule which we have seen a moment back, that HCF into LCM is equals to A into B, that will not be applicable to the questions of 3 numbers, because that rule is for only 2 numbers. Remember this always. Now let's see next question. Consider number 4n, where n is a natural number. Check whether there is any value of n for which 4n ends with digit 0. See, for 4n to end with 0, I need that it should be divisible by 5. If it will be divisible by 5, that means it's one of its prime factors as 5 as well, because 5 is a prime number. Let's factorize 4n. On factorizing 4, I'll get 2 into 2, for which I'll get 2 to the power 2n. This shows that only prime in the factorization of 4n is 2, right? And by fundamental theorem of arithmetic, I can say that there are no other primes that can occur in the factorization of the number. Why is it so? Is it so because fundamental theorem of arithmetic says that this prime factorization for any number is unique. So it means that there cannot be any other prime number in the factorization of 4n. So therefore I can conclude there is no natural number n for which 4n ends with 0. I hope this is clear to you. Okay, now let's move to next question. The question says there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes of the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes they will meet again at the starting point? To understand this problem, let's say this is the circular path. Sonia starts from here. Sonia and Ravi starts from here at the same time. Sonia will complete this one round in 18 minutes. But where will be Ravi in this 18 minutes? He would have completed this round in 12 minutes. He will be somewhat here in its second round, while Sonia Sonia had just completed her first round, right? For this, as they are proceeding in same direction, you have to find the LCM. LCM of 18 and 12. Okay? Let's just find out the LCM. Let's see. 9, 6, I get LCM as 3 into 2 into 2 into 3, right? It comes out to be 36. Therefore, after 36 minutes, Ravi and Sonia will meet at the starting point again. In 36 minutes, Sonia would have completed. Sonia will complete 3 rounds. Sonia will complete 2 rounds and Ravi will complete 3 rounds. And at 36 minutes, Sonia will starting 3rd round and Ravi will be starting 4th round. Okay? I hope this is clear to you. This ends my session of Fundamental Theorem of Arithmetic. I'll be back soon with my next video on irrational numbers. In the meanwhile, practice your NCERT, and if you have any doubt, please comment below in the comment section. If you have find this video useful, please like the video and hit the subscribe button. Thank you.